Dear all, in this video I'll be discussing about the classification of transducer. How do we classify the transducers? As far as the classification of transducer concerned, we have to follow the majorly three criteria. It can be classified based on general features, types of output, and electrical principle involved. And a few more criteria also will be there. First of all, let me show you a flow chart so that you will be getting a broad idea about the entire classification of transducers. So moving on to the flow chart which are regarding the classification of transducer. First and the foremost, based on the general features. Okay, based on the general features, you can divide the transducer into active transducer and passive transducer. Then on the basis of electrical principle involved, you can classify variable resistance transducer, variable inductance transducer, variable capacitance transducer, variable generating type transducers, and voltage divider type transducers. And based on the output, you can divide the transducer into analog transducer and the digital transducer. And based on the method of application, you can divide the transducer into primary transducer and secondary transducer. Finally, based on the conversion, like electrical quantity into non-electrical quantity and non-electrical quantity into electrical quantity, according to the conversion, you can able to divide the transducer into normal type of transducer and inverse transducer. So these are the broad classification of transducer. Next, I wanted to discuss individually. First, I wanted to classify the transducer according to general features. You can divide the transducer into the active type transducer and a passive transducer. So what do you mean by active transducer? In case of active transducer, as the name suggests, no external power or no external excitation is required for the energy conversion. For example, if I talk about thermocouple, we'll be having both the hot junction and cold junction. The difference in junction that is going to produce voltage. That means difference in junction temperature is belong to a mechanical parameter and voltage is an electrical quantity. That means non-electrical quantity will be converted to electrical quantity without an energy supply. That is called active transducer. You can have another example, photovoltaic cell. The input is solar radiation, output will be either current or voltage. Thermopile is also regarding the temperature. Temperature will be converted into electrical voltage. So these are the examples of active transducer. We don't require any external excitation or power supply to operate the energy conversion for active transducer. If I talk about the passive transducer, definitely we need one external power source. External power supply is required for the energy conversion. Okay, for the energy conversion, we require any external power supply. It may be one excitation. You can give some examples such as differential transformers, then thermistors. For thermistors, we require some external DC power supply. So this classification is according to the general features. Okay. So you have to divide the transducer into active and passive transducer according to general features concerned. So these are the various examples of active transducers. See, I have listed out the various examples of active transducers, and there is a broad classification of the passive transducers. They are given here: strain gauge, thermistors, photoemissive cells, photoconductive cells, LVDT. These are the examples of passive transducers. Now, according to the nature of output, it is possible to divide the transducer into analog transducers and second one is called digital transducer. So regarding analog transducer, the output of transducer will be analogous nature. For example, thermocouple, LVDT, thermistor. If you observe the output of these transducer, it will be purely analog. Okay, where digital transducers will be getting the output in the form of pulses. Output will be in the form of pulses. Okay, so such kind of transducers are explained as digital transducers. So this is according to the nature of output. Okay. So that is another important classification criteria. However, analog transducers are most commonly used. Some kind of encoders, okay, that is belong to digital transducers. And analog transducer is cheap compared to digital type transducers. But there are a lot of advantages for digital transducers regarding accuracy. The third classification criteria is according to the electrical principle involved. First one is variable resistance type. So you know that R is equal to rho L divided by A. Okay, so according to that, the resistance is directly proportional to length of the material, inversely proportional to area of cross section. Okay, then you know whenever resistance is high, the output current is very less. Okay, likewise, you can divide according to the variable resistance type transducer. You can give some example also: strain gauge, then pressure gauges, thermistors, resistance thermometer, PV cell, etc. So according to the variable inductance principle, LVDT is one of the best example, linear variable differential transducer. Then reluctance pickup type transducer, then eddy current gauges. These are the popular examples of variable inductance. It works based on the principle of inductance. Okay, you should know that VL is equal to L di by dt. This principle, this equation you have to remember. Regarding the third subclassification, that means according to electrical principle involved, the third one is variable capacitance type. It based on the capacitive principle. Okay, you should have the idea about the Q is equal to CV. Q is equal to CV and I is equal to C dV by dt. From this, you can say that the current is directly proportional to rate of change of voltage. And here voltage is directly proportional to rate of change of current. Okay. Now, according to the variable capacitance effect, you can give some examples of this type of transducer such as capacitor, microphone, pressure gauge, similarly dielectric gauge. These are the popular example. Then fourth class subclassification is voltage generating type. Thermocouple. The input will be the difference between hot and cold junction of the metal. Output will be purely electrical voltage. Similarly, PV cells, then rotational motion tachometer for the measurement of speed, then piezoelectric pickup, etc. These are the popular examples of voltage generating type transducer. If you look at the output of this type of transducer, it obviously voltage, quantity will be voltage, electrical voltage. Now, voltage divider type transducer. For example, potential position sensor, potential position type. It will be either linear or rotational. Then pressure actuated voltage divider type. It obeys the principle of voltage division. Okay, you know the voltage division formula. So this is operating according to the voltage division formula. So we can say that this is one of the important classification criteria. According to that, we can call we can make an example of this type of transducer. These things are comes under one umbrella. Now let us recall the block diagram, the flowchart once again. Here you can able to observe that primary and secondary transducer according to method of application. So can you give some examples of primary transducer? That means thermistor. If you look at the thermistor, in case of thermistor, what is going to happen? The temperature that is going to convert into electrical quantity. So only one conversion, okay, one stage conversion, okay, one stage transferring one stage of energy to another stage. Thermistor, that is the best example. Input will be difference in temperature, output will be electrical quantity, electrical voltage. That is one example for primary transducers. What about secondary transducer? Suppose I'll be considering, so example of primary transducer, I'm going to give it as thermistor or RTD, whatever it may be, thermistor, RTD, etc. So regarding the secondary transducer, I wanted to give a best example, that is Burden tube. Burden tube. So the purpose of Burden tube is to measure the pressure. It involves two transferring stage. There are two steps. The first step is pressure will be converted into displacement. Pressure pressure will be converted into displacement first. You know what is displacement and pressure, you know. Okay, first stage. Regarding the second stage, the displacement that will be converted into voltage with the help of LVDT. The second stage is the displacement. Displacement is converted into electrical voltage. That is electrical quantity. Voltage is an electrical quantity by using LVDT. That is actually happening in case of burden tube. So I must say that the burden tube, that is one of the example of secondary transducer. Once again, I will repeat. In case of burden tube, pressure will be converted into displacement first. Thereafter, displacement will be converted into voltage with the help of LVDT. LVDT is a part of a burden tube. This is actually happening in case of burden tube. So I should say that burden tube is belong to a secondary transducer. In case of thermistor, only one conversion will be taken place. What is the input? Input will be the temperature. So what is the output? Output will be voltage. So only one conversion. Okay, one stage conversion. I should say that only one stage conversion. That is why it is called a primary transducer. Now, finally, I would like to explain one more criteria, that is transducer as well as inverse transducer. What do you mean by transducer? Transducer means it will convert non-electrical quantity into electrical quantity. There are a lot more examples we studied. Then, for example, strain gauge, load cells, etc., all are called transducers. What do you mean by inverse transducer? Inverse transducer in the sense electrical quantity. Electrical quantity is being the input and the output quantity will be the non-electrical quantity. For example, electrical input is electrical signal is the input. Output may be sound. Okay, such kind of transducers are generally depicted as inverse transducer. Hope you understood the difference between transducer and inverse transducer. So this is the broad classification of the transducer. So you can familiar individually. In the forthcoming session, I am going to familiar each and every type of transducer in an elaborated manner. Okay, this is the broad classification. So I could explain only the little bit of points regarding individual transducers. So please stay tuned. I'll be discussing the detailed information about the individual transducers.